Hey guys, welcome to another essential tutorial. So today I'm going to be showing you how you can grow these different structures using Houdini and a growth solver. So let's create a platonic solid first and set the solid type to dodecahedron. And then I'm going to convert these to VDBs. I'm going to go VDB from polygons, and I'm going to keep those settings the same. And then I'm going to drop down a VDB smooth so that we can smooth it out a little bit. Playing around with the iterations, you can control the strength of it. And finally, I'm going to add a convert VDB, and I'm going to change the convert to volume to convert to polygons. So I'm going to also add a mountain sop, and this is just going to allow us to add some noise to the position of each of those points, just so that we can have a bit of variety in the distortion of the mesh. Playing around with the amplitude and the element size, we can control the effect that it has on the mesh. Next, let's finally add our solver. So before I actually wire everything in, let's just do a quick remesh node. And I just want to reduce the overall polygons on this input mesh. Cool. So let's wire that into the first input, and let's jump into our solver. In our solver, the first thing I'm going to create is a switch, and I'm going to wire in the previous frame and the first input. And then I'm going to add a little expression to our select input, $ff equals 1. So what that means is that on the first frame, it's going to equal our first input, and then every frame following that is going to equal the previous frame. And that'll just allow us to grow our mesh over time. So let's add a scatter sop, and that's going to scatter points on the surface of our input mesh, setting it to something like a total count of 15. And now I'm going to wire those points into a copy to point sop. And I'm going to use some basic geometry like a box to copy to each one of those points. So let's scale those boxes down. And then finally, in order to actually have our mesh grow over time, we need to wire in our previous frame into a merge node, combining that with the copy to points geometry. And that's all we have to do. So if I highlight this merge node here and I scale through, you're going to see that now this mesh is growing on. So you can create all kinds of different effects using something like this. I'm just showing you some basic geometry, but there's lots of ways we can kind of change this look to get different effects. So let's jump into our box here. And I'm going to add in a little expression for rotation, $f times 3, which is going to rotate the value in the y direction on each frame. And then I'm going to do the same thing in our z axis. So let's do $f times 2. And so now we kind of get this rotating cube over time. So what does that mean? So if we pipe that into our copy to points, you're going to see that our cubes start to rotate on every frame that they're added in. It just kind of gives a different look here. Cool. So let's also add in something like a poly bevel into our box geometry. That'll just give us a bit more fidelity on the edges of our geometry. And see how that looks. So the thing is, every time you make these changes, you're going to have to re-simulate. So you're going to have to go back to frame 1, and you're going to have to scrub through in order to see those changes take effect. So let's jump back out to the solver view, and let's now add a VDB from polygons in order to merge these meshes all together. So I'm going to add a VDB from polygons, VDB smooth, and you might have to play around with the density of the VDBs in order to have this smoothing geometry not have gaps. So if I change it to something like 0.05, now you can see that there's a lot more polygons to play with. So even just using VDB smoothing, you can create these kind of like tendril effects or like root effects for plants. Or you can even do something like icicles if you had all the geometry point downwards. So there's lots of different ways you can kind of utilize something like this growth solver in order to create different looks. So finally, I converted that all back into polygons, and you can disable the smoothing in order to kind of retain a lot of the original geometry that you had to begin with. So I can kind of create more of like a crystalline structure. So that looks pretty cool. So what else can we do here? So let's jump back into the solver and just playing around even with the input shape. If we were creating something, let's just move these over here. If we were to create something like a sphere, we're going to pipe that in. You can see that I'm going to play around with the scale. So let's just scale this down. And let's just decrease the amount of rows and columns just to keep things fast here. If I was to add something like an attribute randomize to our points and add something like p-scale, we can actually add some variation in the scaling of those particles. So if I isolate the copy to points here, you can see that now each of those spheres have some variety in their scaling. So let's zoom back here. So that kind of gives a different look as well. So what else can we do? Well, if we change the shape to another platonic solid and wire in one of these shapes here, again, just playing around with the scale so that it's not so big. So I'm going to leave it at something like this, wire it into the poly bevel. Just depending on the different shapes that you wire in, there's lots of different looks you can get. And you can even, model something from scratch. If you wanted to have something that looks more like crystals, you can do that as well. So you can also add an orient attribute in order to randomize the rotation of each of those points. So if you just kind of mess around with the values in the X, Y, Z, you're going to see that as you scrub through or change the values of these, that it's going to randomly rotate the angle of each of these points that are being generated. So another thing we can do is we can actually have a random shape be picked on each of these generations. So for instance, rather than having to pick one of these shapes individually, we can have a variant attribute that does it for us. So how do we set that up? Well, if we were to, for instance, copy these poly to bevels, so they're across each of these, and then start with something like an attribute create, we need to create our initial attribute. So let's call it variant. And I'm going to set it to 1, and I'm going to set the type to integer. And again, leaving the point class, because you're going to see it needs to be applied to points in order to work here. Then I'm going to add an attribute randomize, and I want to randomize those integer values. Now I'm going to set it back to variance here for the attribute name, and you want to make sure that the max value corresponds to the max amount of objects you have. So in this case, it's going to create a random value between 0 to 2, so 0, 1, 2. Because for each of these objects I have on the left here, it's going to correspond to 0, 1, 2. So in the attribute create, I'm going to create the variant attribute on this object. Again, setting it to point, I'm going to set the value to integer, and now this value is going to be 0. Copy that over. This value is going to be 1, and the integer value for this next object is 2. So then I'm going to wire these all into a merge node. Let's just check it here. Yeah, so 0, 1, 2 in the variant tab. Let's add in a merge node. Merge all these objects in. Pipe this into the copy to the points. And now when I enable this, if I change the piece attribute to variant, every time the copy to points is running, it's going to randomly be picking from that selection of items using the variant attribute as its selection. So you can see that we have bits and pieces from each of those objects. So now as I grow this on, you can see that it's randomly choosing those objects and adding those to our structure. Pretty cool. So you can do different things like creating, organic structures. If you want to do any kind of like bacteria or something under the microscope, you can do some kind of different, virus type looks. And again, just piping it into the VDB, you can get all different types of looks, especially if you're using any kind of refractive material. Looks pretty good. Anyway, hope you guys learned something on this, and I will see you next time.